Alright, what's up everybody? Today we are performing reflections, okay? Basically what we're doing is we're doing reflections, okay? You can read this stuff later if you'd like. Alright, let's jump right into it. Let's say we have some point, and let's call it point P. And then we have something called a line of reflection. This is called the line of reflection. Okay, it's the thing that we're going to reflect over. And let's take this specific point P, okay, and let's reflect it over this line of reflection. Notice that when I reflect it over, I have to go the same distance to the line and then go the same distance over. Okay, so that is officially reflected. It's kind of like opening the pages to a book, where this is the middle part of the book. So, another thing you need to notice is that the distance from here to the first point, oh, by the way, this is going to be point P prime, right? Because it's the image and this is the pre-image. Okay, so let's go back to this. This line, the distance here is going to equal the same as the distance of the line of reflection to point P. Okay, let's do another one. Let's take point Q. Let's say Q, and let's say it's point here, and we're a little bit farther away, but the same way, we are going to reflect it over this line of reflection. Over here, the same distance over, okay? And when I take the distance from this point to this line, and this point to this line, these distances are equivalent. Oh yeah, this is Q prime. Don't forget that. So over here we have the pre-image, and we go over to the image, performing a reflection over the line of reflection. Okay, let's look at another thing. Let's say that we have this thing over here. You got to notice that if we're going to go over this line of reflection, okay, this is the line of reflection now, what's going to happen to the figure, it's really going to be flipped over. Let's make a copy, let's flip it around, and when it's reflected, okay, it looks like it's opened up and it got flipped over. But the same way, every point between this point to here and this point to here, okay, these are congruent. And from here to here, this line is congruent to this line from here to here. Okay, even if I take a line way over here, all the way to the line of reflection, and here to here, this point is congruent. And that's basically what we're going to be doing when we're performing reflections. All right, let's take an example. Okay, let's say that we're going to reflect over x equals -1. Where is x equals -1? X equals -1 is going to be right here. Let's make a dashed line for x equals -1. Okay, and I'm going to take every point, like I'm going to take this point here, and I'm going to see how far away is from the line of reflection. I have 1, 2. So I'm going to go over 1, 2. And this point is going to be C prime. Alright, actually we ended up not having enough lines here, so let's build some more lines on this graph. Okay, so just because this isn't big enough. Okay, and then let's take this point A, and let's move it over. See how far away it is. 1, 2, 3, 4, 5. Okay, now I have to go over 1, 2, 3, 4, 5. Alright, and that's going to be A prime. Alright, let's take this point B. Let's see how far away is from the line of reflection. I have 1, 2, 3, 4. And again, we go over 1, 2, 3, 4. And this is B prime. Okay, so then I can connect the dots, and all of a sudden, I just reflected over this x equals -1 just by counting the spaces. Notice how this distance here is congruent to this distance here, this distance here is congruent to this distance here, and finally this distance to here is congruent to this distance to there. Okay, let's try another one. If you don't understand that, you can pause it, rewind it, anything you want to do. Would you please try this one before I do it? Please pause it. Alright, well here we go. I'm going to do it. I'm going to reflect over y equals 2. Okay, where is y equals 2? Y equals 2 is always going to be here. This is y equals 2. So my first point, I'll take D. Oh, but D is itself. D prime is right on the line of reflection. You don't have to change it. How far is point C away? So we go 1 away, then we go 1 up. So all of a sudden that's C prime. B is 1, 2 away. Then I count 1, 2 south for B prime. Okay, last one. A is 1, 2, 3 away from the line of reflection. So I go down 1, 2, 3. And here is A prime. Oh, I can connect the points. And that is a perfect reflection over y equals 2. Okay, let's keep on moving on to special reflections, okay? This is all these special ones that we're going to be dealing with. All right, if we have AB and we're going over the x-axis, then the answers are going to be A, negative B. So this is an algebraic way to do this. Let's do an example here. You can copy these down in your notes, but first of all, let's just take it as it is right now, and let's do this one. We're going to reflect over the y equals, so we're going to reflect over the x-axis. Okay, so we're going to use this rule up here, and I'm going to say if I have any point A comma B, it will then turn into A comma negative B. Alright, let's plot the points that we have in the beginning here. First, A is 2, 3. We have B is 1, 2, 3, 4, 5, 6, comma 1. And C is 7, 1, 2, 3, 4, 5, 7, comma 5. So algebraically, my points are going to be plotted like so. If I'm just going to change the b's to negative, then my reflection over the x-axis will end up being 2 comma negative 3. And we will get 6 comma negative 1. And we will get 7 comma negative 5. Okay, let's see if that all worked. So let's plot my points. A is 2 comma 3. And B is 6 comma 1. And C is 7 comma 5. Okay, so there's my original triangle, and I plot my other ones, and I have 2 comma negative 3, and that's going to be A prime, and I'm going to have 6 comma negative 1, and that'll be B prime, and I'll have 7 negative 5, and that is C prime. And this is a perfect reflection over x-axis. Okay, let's try another one. Alright, here is another one, and I'm going to reflect it over y equals x. So we're going to reflect over y equals x. So if I'm going to do that, I have y equals x, and I'm going to use this rule. If I have AB, then I'm going to switch the B and the A. Okay, see how the A and the B just switch over the reflection? So here we go. I have A, and I'm going to call that 1, 2, 3, 4, 5, 6, comma 1, 2, 3, negative 3. And I have B, which is 1, comma negative 2. And I have C, which is 1, 2, 3, 4, comma 1. Right? 4 comma 1. And let's reflect it over y equals x. Okay, so A prime, we are going to have B prime, and we're going to have C prime. Alright, I'm running out of space here. Let me just do it real tight, and I'm going to switch the A's and the B's, and I'm going to have negative 3 comma 6, and I'm going to have negative 2 comma 1, and I'm going to have 1 comma 4. Let's graph our points. I have 6 comma negative 3. I have right here, which is A. I have 1 comma negative 2, which is right here, which is B. And I have 4 comma 1, which is C. Let's draw it, and if I'm going to reflect over the y equals x, which, let's draw y equals x real quick. Do you even know where y equals x looks like? Y equals x is actually this line right here, going right through. That is y equals x. Y equals x. Alright, and the reflection is going to be, a prime will be -3, 6. That is a prime. And b prime is -2, 1. That's b prime. And c prime is 1 comma 4. 1 comma 4. And there is c prime. And now I can draw my nifty triangle, and you can see that it actually is reflected over y equals x, and it works just using these tricks. Okay, let's move on to the next one.
Well,